The expression x to the negative 2, y to the 1/2 over x to the 1/3, y to the negative 1, where x is bigger than 1 and y is bigger than 1. They have to say that because, of the fractional exponents. And I'll explain what fractional exponents mean in a second, or a couple minutes actually. I have to find out which one of these is equivalent to that. All right, so quick little rule. X to the a over x to the b, if I have powers that are dividing each other and the bases are the same, subtract the exponents. So that's what I'm going to do here. I identify the fact that I have an x up here in the numerator and an x down here in the denominator, and I'm dividing powers of the same base, so I want to subtract exponents. Usually when you have to simplify problems like this, you are required to have the exponent be positive. So I'm going to write out a fraction bar here. The exponent down here is positive. The exponent up here is negative. So I'm going to keep my x on the bottom in the denominator and do 1/3 minus negative 2, which is the same as 1/3 plus 2. Plus 2. I'm going to turn 2 into 6 over 3. So 1/3 minus negative 2 is the same as 7 over 3. Now let's do the same thing with y. I have y to the 1/2 in the numerator, y to the negative first in the denominator. I have to do 1/2 minus negative 1, which is the same as 1/2 plus positive 1, which is 2 over 2. And I get y to the 3 over 2 on the denominator. Numerator, numerator, numerator. Now another fun rule is if you have a fraction for an exponent, this is what I meant when I said we'll deal with it in a second, and then I changed it to a minute. If I have x to the, we'll say m over n. X to the m over n is the same as the nth root of x to the mth power. Okay, it could also be written as this, the nth root of x, all of it to the mth power. But as you can see, we're not going to see that version of the problem in my answer. So I'm going to make this fraction over here look like that. Y to the 3/2 is the same as the square root of y to the 3rd over x to the 7/3 is the same as the cubed root of x to the 7th. Now, in normal circumstances, you would look at a problem like this and be like, that's great. I think I'm done now. Oh, but we're not. They want us to simplify the roots. So I'm moving this over here because I have a little way that I do these. It's kind of, unique to the way I handle it. Maybe not the fastest way to do it. Speaking of not the fastest way to do it, moving all of these one by one probably wasn't the fastest way either, but I was able to talk and vamp. This is how I simplify square roots, cube roots, whatever roots you're dealing with. You take that root and you break it up as much as possible. Y. You take that cube root and you break it up as much as possible. X. If you have a square root, you circle every group of identical factors inside that root. You bring out one of them. If you can't circle any more, you leave it. So after I bring out one of them, I have y times the square root of y. Since this is a cube root, I'm going to circle a group of 3 x's and another group of 3 x's. I would bring out 2 x's, giving me x squared, and I'm left with the cube root of 1x on the inside. So after all those little rules, all of those little tricks, I have y times the square root of y over x squared times the cube root of x. My answer is D. I love problems like these. And I'm sure you're looking at that and it's like, that took a lot of time. I know. But it's kind of like a puzzle for me. I enjoy it. I love it.